April 10th, 2019. 6 press conferences, 6 cities, 1 image. The orange ring goes up on the screen, the room applauds, and within a day it is on 4.5 billion phone screens, framed everywhere as the first photograph of a black hole. Hold that memory for a second, because 3 things about it are wrong. A black hole emits nothing. By definition, it is invisible, and nothing in that frame is the black hole. The dark center is not the event horizon either. It is roughly 2.5 times too wide, and no camera took it. There was no photograph. There was a reconstruction, assembled by algorithms out of data far too sparse to form a picture on its own. None of that is a rumor. All of it is in the papers the team published that same morning. It just never made the headline. Let me be exact about what I am claiming. I am not saying the observation was faked. I am not saying the ring is imaginary. I am not saying the scientists lied. And I am not about to tell you black holes do not exist. The Event Horizon Telescope did something genuinely extraordinary in 2017, and the people who built it are among the most careful researchers alive. That is exactly the problem. They were careful. The papers were careful. The press release was not. The coverage was not. And the gap between what was measured and what the world was told is not a rounding error or a bit of harmless simplification for the public. That gap is the whole story. Because here is what actually sits in that image, and I want you to sit with it for a moment before we go anywhere else. You are not looking at an object. You are looking at light. Specifically, you are looking at light emitted by superheated gas that was never inside the black hole, that escaped from a region outside it, that was bent on its way out by gravity so extreme it curves the path of a photon back around on itself, and that then traveled for 55 million years across intergalactic space before landing in 8 radio dishes on this planet in April 2017. The black hole itself contributes exactly one thing to that picture: absence. It is the part where nothing arrives. That is the first reversal, and it is worth saying plainly. The most famous scientific image of the 21st century is a picture of the outside of something we cannot see, taken by an instrument that does not produce pictures, showing a boundary that is not the boundary everyone thinks it is. Now, why should that bother you? You could argue this is pedantry. Scientists communicate in caveats, journalists communicate in headlines, and the two never match perfectly. Everyone knows that. Fine. Except the caveats here are not stylistic, they are structural. Each one of them, followed honestly, leads somewhere harder than the headline. And when you follow all of them together, they arrive at a conclusion most people have never heard stated out loud. Start with the dark center, because that one is measurable and unambiguous. The bright ring in the image is about 42 micro-arc seconds across. The dark region inside it is not the event horizon. It is what physicists call the shadow, and its size is set not by the horizon, but by the photon capture radius, the point where light that gets too close can no longer escape on any trajectory at all. Run the geometry for a non-rotating black hole, and the shadow comes out about 2.6 times wider than the horizon itself. That is not a small discrepancy. That means the actual boundary, the thing the image is named after, the surface everyone believes they were looking at that morning, sits deep inside that dark patch and was never resolved. Not partially, not approximately. It was not in the frame. Take the second one. There was no photograph, and I do not mean that in a philosophical sense. The Event Horizon Telescope does not record images. It records interference patterns between widely separated radio dishes, timestamped by atomic clocks, and those patterns sample only a fraction of the information a real image would require. The rest has to be filled in. Not invented, filled in, using algorithms that choose among an effectively infinite family of possible images, all of which fit the same data. The team knew this was the vulnerability. That is precisely why they split into 4 independent teams, working blind, using 2 fundamentally different methods, forbidden from comparing results until the end. That precaution is admirable. It is also an admission. You do not need blind teams when you have a photograph. And take the third, which is the one that eventually swallows the other 2. Even with perfect data, even with an image sharp enough to resolve the horizon directly, no observation could ever confirm that an event horizon is there. Not this telescope. Not a better one. Not any instrument built on any principle we currently understand. The best any measurement can do is put a limit on how much the object differs from a black hole. That is a very different claim from the one printed on the front page. So here is the thesis, stated early, because this is not a mystery, and I'm not going to make you wait for it. What was announced as a triumphant confirmation was, read honestly, a demonstration that the most important boundary in physics is permanently out of reach of observation. The image did not close a question. It marked the exact place where our two best theories of reality stop agreeing with each other, and then it was released under a caption that made it sound like a finish line. The paper said consistent with, the world heard image of. Everything that follows lives in the distance between those two phrases, and that distance gets wider the closer you look at it. Because before you can ask what the picture shows, you have to ask something simpler and much stranger. If the telescope never produced an image, then something, somewhere, had to decide what the picture looked like. Before we go further, I am curious where you are watching this from and what time it is where you are. Drop it below, and be honest with yourself about one thing while you do, because it matters for everything that comes next. When you first saw that image in 2019, did you assume it came out of a telescope the way a photo comes out of your phone? Point it, focus it, capture what is there. Almost everybody did. That assumption is doing an enormous amount of work in how the public understands this result, and it is completely wrong. Here is what actually happened in April 2017. 8 radio telescopes at 6 sites, from the summit of Mauna Kea to the Chilean desert to the Spanish Sierra Nevada to the South Pole, were pointed at the same patch of sky on the same handful of nights. They were not connected. They could not be. There is no cable that runs from Hawaii to Antarctica. Instead, each site recorded raw voltage from its receivers onto banks of hard drives, and each recording was stamped with time signals from a hydrogen maser, an atomic clock stable enough that it would drift by less than a second over 10 million years. That timestamp is the only thing linking the dishes together. Without it, the data from 8 sites is 8 piles of noise. Nobody at any of those telescopes saw anything that night. Nobody looked at a screen and said, there it is. Each site captured what looked like static at 32 gigabits per second, and the entire scientific content of the observation existed only in the relationship between those piles of static. A relationship nobody could examine until they were in the same building. The recordings came to roughly 5 petabytes. That is more data than exists in the entire catalogue text of every book ever written, several times over, gathered in a handful of nights. It was far too much to transmit over any network on Earth in any reasonable time. So they flew it, physically. 1/2 ton of hard drives packed into crates, loaded onto cargo aircraft, and shipped to correlator facilities in Massachusetts and Bonn. The most precise astronomical observation ever attempted moved across the planet at the speed of air freight, and it did not all arrive. The South Pole telescope had its drive sitting on the ice, while Antarctic flight operations were shut for the winter. That data could not leave the continent until the season reopened. It landed in December 2017, roughly 8 months after the observation, and only then could the full analysis begin. Sit with the image for a second. The definitive test of general relativity in the strong field regime, delayed for most of a year because it was winter somewhere and the planes could not land. Now, why am I dwelling on logistics? Because it tells you what kind of instrument this actually is. Not a camera, a sampling machine. Each pair of dishes measures one specific spatial frequency of the sky, one particular scale of structure, and nothing else. 8 telescopes give you 28 possible pairs, and as the Earth rotates, those pairs sweep out arcs across what radio astronomers call the UV plane, the map of everything you have sampled. When the campaign was over, those arcs covered a thin, sparse scattering of that map. The vast majority of it was empty. It is still empty. It will always be empty for reasons we will get to. So the raw output of the Event Horizon telescope in 2017 was not a blurry picture that needed sharpening. It was a set of measurements consistent with an infinite number of different pictures, and the job of the analysis was to decide which of those pictures to believe. That is not a scandal. That is how the technique works, and it works well, and it has been validated for decades. But it is a completely different epistemic situation from the one the public was handed, and the difference matters, because the history of physics has a specific and recent lesson about what happens when a technically beautiful result gets announced in a tone the data cannot support. In March 2014, the BICEP2 collaboration held a press conference at Harvard. They announced the detection of primordial gravitational waves from the first fraction of a second of the universe, direct evidence of cosmic inflation. There is video of Andre Lind, one of inflation's architects, being told the news on his doorstep and reaching for the doorframe. The coverage was immediate and enormous. Nobel talk began within hours. The signal was galactic dust. Not entirely, but enough. Within months, Planck's satellite data showed that dust in our own galaxy could account for the polarization pattern, and by early 2015, a joint analysis had effectively withdrawn the claim. Nobody had cheated. The instrument worked. They had announced a conclusion at a confidence level the foreground contamination did not permit in a room full of cameras before anyone could check. I am not saying the black hole image is BICEP2. I want to be very clear about that, because that comparison gets thrown around carelessly. The EHT result has survived far more scrutiny, from far more directions, and as you will see, it has held up in ways BICEP2 never did. The comparison is not about validity, it is about the mechanism. It is about how a field that speaks in confidence intervals internally converts, at the press conference boundary, into a field that speaks in declarations. That conversion happens every time. It happened here. So, 8 dishes, 5 petabytes, sparse sampling, months of processing, and no image anywhere in the pipeline until somebody made one. Which forces the obvious question, the one almost nobody asked in 2019, because the picture was so beautiful that asking felt rude. If the data alone does not determine the image, what does? What decided that the light in that frame should form a ring rather than something else entirely? And once you know the answer, can you still call the result a discovery in the way we usually mean that word? To answer that, you first need to know what is actually glowing. Everything you can see in that image is gas that got too close and is now dying loudly. M87 is a giant elliptical galaxy about 55 million light-years away. And at its center is a mass of 6.5 billion suns compressed into a region smaller than our solar system. Material that drifts within reach of it does not fall straight in. It has angular momentum, so it spirals, and as it spirals it forms a hot, turbulent, magnetized flow. Friction and magnetic stress heat that flow to temperatures in the billions of degrees. At those temperatures, atoms are stripped bare. You have free electrons moving at nearly the speed of light through a tangled magnetic field, and any charged particle forced to curve in a magnetic field radiates. That radiation is what the telescope caught. Synchrotron emission at a wavelength of 1.3 millimeters from plasma that is orbiting a drain it will never come back out of. So the glow is real matter, at a real temperature, doing something violent. But that alone does not make a ring, and this is where it stops being intuitive. Gravity that strong does not just pull, it bends the paths that light itself is allowed to take. Close enough in, a photon's trajectory curves so severely that it can loop most of the way around the black hole before escaping outward toward us. Which means some of the light in that image did not come from the near side of the object at all. It came from behind it, from the far side of the flow, wrapped around the back and delivered to our telescopes as if it had been in front the whole time. Let that land properly, because it is genuinely strange, and it gets skated over constantly. You are looking at an object whose gravity is folding its own reverse side around into view. The bright ring is not a physical ring of matter sitting there like the rings of Saturn. Some of it is the accretion flow seen directly. Some of it is the same flow seen from behind, bent forward. And nested inside it, thin and sharp, is what theorists call the photon ring, made of light that orbited the black hole one or more complete times before it got out. That component exists in every image ever made of this object and has never been resolved on its own. It is thinner than anything the instrument can separate, So the correct description of the picture is not a hole with a glow around it. It is a lens made of gravity, projecting a distorted image of its own surroundings, with a dark spot in the middle where the projection runs out. Now the number, and this is the one that should reset your sense of what was achieved. The ring is 42 micro-arc-seconds across. A micro-arc-second is 1/1,000,000th of 1/3600th of a degree. At that angular size, you are resolving an orange sitting on the surface of the moon. That comparison is standard because nothing else quite conveys it, so try it from the other end. Every optical telescope built before this, Hubble included, would register that entire structure as a fraction of a single pixel. Not a small blob. Not a smudge to be sharpened. Less than one detector element, indistinguishable from a point of light. That is the scale at which this measurement lives, and it means something specific about what could possibly be in the frame. At 42 micro-arc-seconds across, spread over maybe a dozen effective resolution elements, there is no fine structure to find. There is a bright asymmetric annulus and a dark interior, and that is the entire information content. Everything else you think you see in that image, the texture, the depth, the sense of an object suspended in space, is your visual system supplying what is not there. And this is where the humanizing point matters, because it is easy to hear all of this as a technicality about resolution. It is not. It is a statement about permission. We were never looking at a place. We were looking at the shape that a place presses into somebody else's light. The black hole did not send us anything. It cannot. It has no surface, no brightness, no emission of any kind. And the only reason we know where it is in that frame is that a specific region contains less light than its surroundings. Astronomy has always been the study of things that shine. This was the first time we tried to study something by mapping the exact contour of its refusal to shine. There is one more layer here, and it is the reason M87 was chosen over the black hole at the center of our own galaxy. Size sets timescale. The larger the black hole, the longer it takes light to cross it, and the slower the flow around it can visibly change. For M87's monster, that timescale is days to weeks. The structure sat still long enough to be observed across a multi-night campaign. Sagittarius A, more than 1,000 times lighter, changes in minutes. The flow reorganizes itself faster than the Earth can rotate the telescope array into position, which is why that image took 3 more years and a fundamentally harder analysis to produce. We did not photograph the closest black hole first. We photographed the one that would hold still. So here is where we stand. The light is real. The mechanism is understood, verified across decades of radio astronomy, and not seriously in dispute. The ring is what general relativity, plus a hot magnetized flow, predicts you should see. And every bit of it is exterior. That is the constraint that never goes away, no matter how good the telescopes get. Every photon that reaches us left from outside. The interior emits nothing and receives everything. There is no observational channel from inside to outside. Not a faint one, not a difficult one, none at all, by the definition of the object we are claiming to have imaged, which leaves us with a picture assembled entirely from the outside of a boundary we cannot see, using data that does not by itself determine the picture. And that last part is the piece nobody puts in the press kit. Imagine a piano with 88 keys, and you're allowed to hear 12 of them. From those 12, you have to write down the entire piece. That is roughly the position the Event Horizon Telescope was in, and it is not an exaggeration invented for effect. It is the mathematical situation described in the collaboration's own methods paper. Here is the underlying problem. Each pair of telescopes measures one component of the sky's structure, at one scale and one orientation. 28 pairs, smeared into arcs by the Earth's rotation over the observing window, produce a set of samples across the plane of all possible structures. That plane is continuous and infinite. The samples are finite and sparse. Between them lies everything you did not measure, and the true image lives partly in those gaps, which means the reconstruction is not a calculation with one answer. It is a selection. There is an infinite family of images that reproduce your measurements exactly, and they do not look alike. Some are rings. Some are pairs of blobs. Some are structures no astronomer would ever accept. The data does not distinguish between them. Something else has to. That something else is called a prior, or in the older approach, a set of cleaning parameters, and it encodes assumptions. That the image should be mostly smooth, that it should not have wild negative regions, that the flux should be distributed in a way consistent with what we expect emission to look like. Every one of those assumptions is defensible. Every one of them is also a choice made by a human being before the data was allowed to speak. Now the collaboration knew exactly how this looked, so they did something genuinely rigorous, and I want to give them full credit for it. They split into 4 independent imaging teams. The teams were forbidden from communicating results. 2 used clean, a technique that has been the workhorse of radio interferometry since the 1970s. 2 used regularized maximum likelihood, a newer approach with different assumptions and different failure modes. They ran the pipelines on synthetic data with known answers, including deliberately misleading test images, to see what the methods would invent. Only after all of that did they compare. All 4 produced a ring, of roughly the same size, brighter on the southern side. That is a strong result. I want to say that clearly, because what comes next gets misused by people who did not read past the headline of the criticism. In the years that followed, a group led by Makoto Miyoshi at the National Astronomical Observatory of Japan reanalyzed the public data independently and argued that the ring structure could be, at least in part, an artifact. Their case was technical, that with sampling this sparse, the characteristic response pattern of the array itself can imprint ring-like features onto a reconstruction, and that certain parameter choices in the pipeline amplified that tendency. It is a serious critique from serious people. It was published, it was debated, and it has not simply been waved away. It has, however, been answered from several directions. Independent groups reprocessed the data with fundamentally different frameworks, including fully Bayesian methods that make their assumptions explicit and propagate uncertainty rather than producing a single best picture, and they recovered a ring. More decisively, the collaboration's 2018 observing campaign was analyzed separately with an expanded array and published in early 2024. The ring was there again at the same diameter, and the bright spot had moved, rotating around the ring by an amount consistent with what the turbulent flow models predicted it should do over a year. That is not what an artifact does. Artifacts do not obey your dynamical predictions on a schedule. So the ring survives. Let me be unambiguous about that. I am not telling you the picture is fake, and I am not endorsing the strongest version of the critique. The measured angular size has been confirmed by multiple pipelines, by an independent campaign, and it agrees with the mass derived decades earlier from the motion of stars in that galaxy's core. Here is what the episode actually proves, and it is more uncomfortable than either camp usually admits. It proves that this result required an argument, not a look, an argument. Blind teams, synthetic validation, parameter surveys, a second observing season, and a multi-year public dispute in the literature about whether a specific feature was real. That is precisely the workload you take on when you are inferring an image rather than capturing one. And it is the workload nobody outside the field ever heard about, because the version that reached the public was a finished, warm, gently blurred orange picture with a caption that used the word photograph. Read that gap carefully, because it is the shape of the entire problem. Inside the collaboration, a distribution of plausible images, a defended central estimate, and an honest fight about its features. Outside, certainty. Not manufactured certainty, not deceit, just the automatic compression that happens when a probability distribution has to fit into a headline. The scientists said consistent with a black hole shadow. The world heard we took a picture of a black hole. And once the world hears that, it stops asking anything else, which is how a genuinely contested reconstruction becomes a settled fact in the public mind within about 48 hours. We imaged it, and we inferred it are different verbs. They imply different levels of certainty, different kinds of evidence, and completely different responses to new information. One of them was true. The other one is the one everybody remembers. But suppose you grant the collaboration everything. Suppose the reconstruction is perfect. The ring is exactly right. The critics are entirely wrong. And the picture is as good as any picture could possibly be. You still have not seen an event horizon. Not one part of it. And that is not a limitation of the analysis, or the array, or the funding. It is geometry. And it is about to get much worse. Take the image and point at the dark middle. Almost everyone who does that believes they are pointing at the event horizon. The name of the instrument encourages it, the Event Horizon Telescope. The papers were titled around the shadow of the supermassive black hole. The public collapsed the two into one thing, and they are not one thing. The dark region is called the shadow, and its edge is not the horizon. It is set by the critical impact parameter, which is a statement about trajectories rather than surfaces. Light that approaches with too little sideways momentum cannot escape on any path. That threshold defines a silhouette, and because gravity magnifies, the silhouette is projected outward, larger than the object casting it. For a non-rotating black hole, the arithmetic is exact. The shadow comes out about 2.6 times wider than the event horizon. So the boundary that everyone believes they saw sits deep inside the darkness, occupying less than 40% of its width, invisible then and invisible now. That is not a subtlety about pixels. The single most important surface in gravitational physics has never appeared in any image, and the image named after it does not contain it. Now, how big is the thing we are talking about? 6.5 billion solar masses. Feed that through the standard relation, and the Schwarzschild radius comes out at roughly 128 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. Here is what that looks like from inside a life. Light from the Sun reaches your face in 8 minutes and 20 seconds. Neptune orbits at 30 astronomical units. Pluto averages 39. Voyager 1, launched in 1977, has been traveling for almost half a century at a speed no crewed vehicle has ever approached, and it is currently somewhere past 160. So the radius of this black hole is comparable to the entire distance humanity has physically covered in the whole history of space exploration. The horizon diameter is roughly twice that again. You could place the Sun at the center and every planet and the Kuiper Belt and the whole of Voyager's journey and still be inside. And the entire structure is too small to see. That is the sentence I want you to hold. An object that would swallow the solar system whole, and at 55 million light years it presents as 42 micro arc seconds, which is why it took 8 telescopes across the planet, 5 petabytes of data, atomic clocks, cargo flights, and 2 years of analysis to produce a blurred orange annulus about a dozen resolution elements wide. Now here is where intuition betrays almost everyone, and this is the point of this section. Most people process 2019 as a beginning. First image. Naturally the second one will be sharper, the 10th will be routine, and eventually there will be a catalogue. That is how technology usually behaves. Cameras improved, microscopes improved, telescopes improved. Why not this? Because the difficulty here does not scale with effort. It scales with the sky. Apparent size is mass divided by distance, and the universe is not generous with that ratio. Run the census. Across the entire observable sky, in every direction, at every distance, there are exactly 2 black holes whose angular size is large enough for an Earth-based array at this wavelength to resolve their shadows at all. M87 star and Sagittarius A star at the center of our own galaxy. That is the list. Not the list of good targets, the list. Everything else falls off a cliff. The next candidates, the ones people actually name in proposal documents, come in at a small fraction of the angular size, which is not a matter of a bit more integration time or a slightly better receiver. Resolution is set by the length of your baselines divided by your wavelength, and neither of those is a knob you can simply turn. So the pattern here is not the usual technological one, where the first hard version gets easier every decade. It is closer to the opposite. The first 2 are the only 2. There is no third target waiting for the technique to mature, because the limitation is not the technique. It is that space is large, and black holes, for all their mass, are physically tiny compared to the distances involved. I said I would flag where the honest uncertainty lives, so here it is. Nobody has ruled out that clever future methods could squeeze partial information from smaller targets, and there are real proposals for detecting the sharp inner photon ring interferometrically without imaging it. Those are worth pursuing and might succeed. But every one of them extracts a number, not a picture, and none of them changes the fundamental point, which is that the population of black holes we can spatially resolve is not going to grow the way a photographic archive grows. Which reframes April 2019 in a way that never made it into the coverage. That morning was not the opening of a new observational era with a long runway ahead of it. It was the near simultaneous discovery and exhaustion of a capability. We reached the target, and in reaching it, we found out how few targets there are. And even for those two, even with perfect data, even with a resolution 100 times better than anything now possible, there is one thing the observation is structurally incapable of delivering. It cannot tell you whether an event horizon is actually there. That sounds like a rhetorical flourish. It is not. It is a specific claim about what a horizon is, and once you understand what would actually happen to a person who crossed one, you will understand why no instrument ever will settle it. Everything so far has been instruments and geometry. Let me put a body in it, because that is where this stops being abstract and starts being genuinely disturbing. Popular culture taught everyone the same thing about falling into a black hole. You get stretched. Spaghettification. Feet pulled harder than head, the body drawn out into a thread, torn apart at the threshold. It is vivid, it is memorable, and for a black hole the size of M87s, it is completely wrong. Tidal force is the difference in gravity across a distance, and it depends on how sharply the field changes, not how strong it is. Near a small black hole, the field changes brutally over a few meters, and a human being is destroyed well before reaching the boundary. Near a black hole of 6.5 billion solar masses, the curvature at the horizon is so gentle that the difference in pull between your head and your feet is smaller than what you feel standing in this room. So here is what crossing the event horizon of M87 star would actually be like. Nothing. No jolt, no pressure, no membrane, no shimmer, no sound, no alarm, no visible line in space. You do not pass through a surface, because there is no surface. You would fall through the most absolute boundary in physics, and there would be no local measurement of any kind that could tell you it had happened. You could run every experiment you know, weigh things, bounce light off the walls, check your instruments. All of them would report normality, because the horizon is not a place where the laws of physics change. It is a place where a fact about your future changes. Look back and the stars are still there. Distorted, displaced, their colors shifted, crowded into a strange arrangement by the curvature you are falling through. But there. The outside universe does not vanish. This is one of the strangest features of the whole picture, and it gets almost no airtime. The horizon is not a wall you slam into, it is a one-way valve you never notice passing through. Light continues to fall in from outside forever. It just cannot go back out. And here is the sentence that makes it real. Somewhere behind you, the people who watched you go are still receiving your light. Not for an instant. For a very long time, growing dimmer and redder and slower, your final signal stretching out toward them, your last seconds smeared across their years and then their centuries, never quite arriving at an ending. From outside, you never finish crossing. You freeze, you fade, and you are still technically there, dimming toward nothing forever. From inside, you fell through at full speed and felt nothing at all. Both descriptions are correct. That is not a paradox to be resolved. That is what the theory says, and it is the reason the word horizon is used rather than surface. It is a boundary defined entirely by where light can get to. Outside, some paths lead out. Inside, none do. Not because something is blocking them, because outward, as a direction, stops existing. The singularity is not a location ahead of you in space. It is a moment ahead of you in time, and you can no more avoid it than you can avoid next Tuesday. For M87 star, the interval between crossing and the end is on the order of a day, not a metaphorical day. Roughly a day of ordinary experience time, in which you are alive, conscious, able to think, able to look around, and already inside a region from which no information will ever escape. You would have time to write everything down, time to reach conclusions, time to understand exactly what had happened to you and record it carefully, and none of it can ever be transmitted, not delayed, not degraded, not eventually recovered by better technology, gone in a way that has no equivalent anywhere else in nature. That is the human meaning of an event horizon, and it is also the scientific crisis at the center of this story. Because if crossing produces no local signature, then the horizon has no observable properties from inside, and since nothing comes back out, it has no direct observable properties from outside either. What we can measure is the region around it, how light bends, how gas orbits, how much radiation escapes. All exterior. Every single measurement forever is a statement about the neighborhood. So consider the actual logical situation. To confirm an event horizon, you would need evidence that no signal can escape from inside a certain surface. But the only evidence available is the absence of signals. An absence is compatible with an enormous number of alternatives, including objects that have a surface which happens to be extremely dark, extremely compact, or extremely slow to re-emit what falls onto it. Physicists have taken this seriously and built the alternatives explicitly. Gravastars, boson stars, fuzzballs from string theory. Most are contrived, and several have severe stability problems. But here is the part that matters. Several of them cast a shadow of nearly the same size, because the shadow is set by light bending outside the object, which depends on mass. Put a gravastar of 6.5 billion solar masses in M87 and the ring looks broadly similar. Observations can constrain these models. They have. Limits on emission from a hypothetical surface are genuinely tight, and the case for a true horizon is strong. But constrain is not confirm, and the gap between them is not going to close, because it is not a gap in our data. It is a gap in what evidence can, in principle, do. Which raises an obvious question. If that is the situation, why does the messaging still sound like the beginning of a golden age? Part of the answer is institutional, and we will get there. But part of it is physical, and it is sitting on the floor beneath your feet. There is a formula that decides everything about this project, and it is short enough to hold in your head. Resolution equals wavelength divided by baseline. The wavelength is how you are looking. The baseline is how far apart your telescopes are. Make the wavelength shorter or the baseline longer and you see finer detail. There is no third option and no clever workaround. The 2017 campaign observed at 1.3 millimeters, with baseline stretching from Hawaii to the South Pole. That is close to the full diameter of the planet. 12,742 kilometers, and the array was already using most of it. So read the formula again and notice what it says about the future. To double the resolution, you either halve the wavelength or double the baseline. Doubling the baseline means an array 25,000 kilometers across, which does not exist on this world because the world is not that big. That option is closed, not difficult, closed, which leaves wavelength, and that is where the atmosphere becomes the antagonist. Water vapor absorbs millimeter radiation, pushed towards shorter wavelengths to 0.87 millimeters and below, and the atmosphere becomes progressively more opaque, which is why every EHT site sits on a high desert plateau, a volcanic summit, or the polar ice in the driest places the planet offers. The collaboration has been extending to those shorter wavelengths, and it does help. But the technique needs all of the sites to be usable at the same time. Not most, all, or close to it, because every dish you lose deletes several baselines from an already sparse map. Now put that in human terms. This is an observation that requires clear, dry, stable skies simultaneously in Chile, Hawaii, Arizona, Mexico, Spain, and Antarctica, across a narrow observing window each spring at the same hours on the same nights. One weather system in the wrong place, and the campaign degrades. Two, and it may be worthless. The most advanced imaging in the history of astronomy is, in practice, a negotiation with the weather on 4 continents. And it is a negotiation you can only open a few nights a year. These are not dedicated instruments. ALMA is the single most important element in the array, the one whose collecting area anchors the entire calibration, and it is a general-purpose observatory with a global user community fighting for time. Every EHT campaign is a temporary requisition of facilities that other astronomers also need. That is not a scandal. It is how shared infrastructure works, but it caps how often this can be attempted regardless of budget. So the honest description of the current state is this. The baseline is maxed. The wavelength is close to the atmospheric limit. The site count is limited by geography, funding, and the number of places on Earth dry enough to be worth building on. The observing cadence is limited by shared access and by weather. And the target list, as we established, has 2 entries. Every axis is near its stop at the same time. That is not what the beginning of a field looks like. That is what a ceiling looks like. The obvious response is to leave the planet, and the collaboration has said so. Putting one-on-one dishes in orbit breaks the baseline limit, and also removes the atmosphere, which solves the wavelength problem in the same move. Concepts exist. Studies have been funded. The Black Hole Explorer mission has been developed as a space element that would work with ground stations to sharpen the photon ring measurement.
Now apply the standard translation that this niche exists to perform, because a mission concept is not a mission. Space astronomy runs on timescales that outlast careers. The James Webb Space Telescope was proposed in the late 1980s, approved in the mid-1990s, and launched on Christmas Day 2021, roughly $10 billion and 2 full decades of schedule slip later. LISA, the Space Gravitational Wave Observatory, was conceived in the 1990s and is currently targeting the mid-2030s. These are not stories of incompetence. They are the normal metabolism of orbital science, and any honest reading of the Black Hole Explorer timeline has to assume the same physics of institutions. Which means the practical situation is this. The best images we have of the 2 only resolvable black holes in the sky were made in 2017 and 2018, published in 2019 and 2024, and the technique that produced them is within sight of its physical limit. Meaningful improvement requires hardware in space that does not yet exist, has not been fully funded, and would arrive optimistically in the 2030s. I want to be fair here because it would be easy to make this sound like futility, and it is not. The ground array is still being improved. More sites are joining. Shorter wavelengths, wider bandwidths, and better calibration are all delivering real gains. And the movement of the bright spot between 2017 and 2018 is exactly the kind of result that a maturing array produces. This is a working field doing good work. But there is a difference between improving a measurement and opening a frontier, and the public was sold the second one. Here is the part that should sit uncomfortably. When the ceiling is that close and that hard, the difference between what an observation can settle and what it cannot becomes permanent rather than temporary. Under normal scientific progress, an unanswered question is a to-do item. Better instrument, later decade, problem solved. That habit of mind is so deep that most people apply it automatically, including to this. It does not apply here. The horizon will not be resolved by a better telescope. It cannot be, and we walk through why. Which means the caution in those 2019 papers, all that careful hedged language about consistency with the predictions of general relativity, was not provisional caution awaiting better data. It was the permanent state of the claim. So why has almost nobody heard it that way? That answer is not about physics at all. Put the 2 documents side by side. Not the science and the conspiracy theory. The science and the press release, both produced on the same day, by the same collaboration, about the same result. The papers are hedged in the way careful papers are always hedged. Emission consistent with predictions. A shadow whose size is compatible with a Kerr black hole of the inferred mass. Alternatives disfavored rather than excluded. Systematic uncertainties enumerated at length. The word photograph does not do any load-bearing work in that literature, because the people writing it knew precisely what an interferometric reconstruction is. The public-facing language did something different. It declared, first image, seeing the unseeable, a picture of a black hole. And the visual itself was prepared for that reception. A warm orange color map applied to radio data that has no color at all. A deliberate blur to suppress features the array could not actually support. An orientation chosen for legibility. Every one of those decisions is standard and defensible in isolation. Together they produce an artifact that reads to the human eye as a photograph of an object, which is the one thing it is not. Nobody lied. I keep saying that because it is true and because the alternative reading is lazy. What happened is more interesting and much more difficult to fix. Large collaborations live on a funding cycle that runs on public attention. An array like this exists because agencies in multiple countries agreed to sustain instruments whose value is legible mostly to specialists. When your result has to justify a decade of that, and when it has to compete for a news cycle against everything else happening that week, hedged language does not survive the trip. It is not censored. It is compressed, then compressed again, and each compression drops the uncertainty first, because uncertainty is the least quotable part of any finding. The result is a systematic asymmetry. The confidence in public science communication is almost always higher than the confidence in the underlying paper, and the error runs in one direction every time, structurally, regardless of the integrity of the individuals involved. There is a precedent for this, and it is the founding one. May 1919. Arthur Eddington leads expeditions to Principe and Sobral to measure whether starlight bends around the sun during a total eclipse. The result is announced that November, and it makes Einstein a global celebrity overnight, one of the most consequential press events in the history of science. The data was messier than the announcement. 3 sets of plates were taken. The Principe plates were partly clouded and gave a weak measurement. One Sobral instrument produced a result close to Einstein's prediction. The other Sobral instrument, the astrographic telescope, gave a value close to the older Newtonian figure, and that set was down-weighted on the grounds that the telescope had suffered a focus problem in the heat. There has been a century of argument about whether that judgment was scientific or motivated. Here is the honest verdict, and it is the reason this comparison is useful rather than cheap. A careful reanalysis in the 1970s with modern methods found that Eddington's decision was defensible and his conclusion correct. General relativity is right, the bending is real. Eddington was not fooling anyone, but look at the shape of it. The right answer, announced with a confidence the data did not yet carry, at an event engineered for maximum impact, with the inconvenient plates handled quietly. It worked. The theory held up. And the episode established the template that modern physics has followed ever since. Announce first, defend later, and let the public keep the clean version. That is the template being run in April 2019. Not the fraud version, the Eddington version. Probably the right answer, delivered with a certainty that belongs to a later stage of the argument. And I will state the fairness clause plainly, because this section is where it is most needed. I am not saying the EHT scientists are dishonest. I am not saying the funding motive corrupted the physics. I am not saying the ring is wrong. I am not saying that public science communication should be conducted in confidence intervals, which would be unreadable and would help nobody. I am saying that when the compression only ever runs one way, the public accumulates a picture of science that is systematically more settled than the science is. And that has a cost which is not paid in the news cycle. It is paid later when a result is refined and it looks like a reversal, when a caveat surfaces and it looks like a cover-up. We have watched that dynamic tear through public trust in other fields within the last several years, and the mechanism was identical, not lies, just certainty issued early and revised in public. But here is the thing about this particular case, and it is why I've spent this long on a caption. The thing being underplayed is not image quality. It is not resolution or processing or how many pixels are real. Those are technical footnotes, and the collaboration handled them better than almost anyone would have. What is being underplayed is what the image implies.
Because if you take the results seriously, exactly as published, with no skepticism about the ring at all, you are not looking at a triumphant confirmation of our understanding of gravity. You are looking at photographic evidence, so to speak, of the precise location where our understanding runs out.
and the world was invited to celebrate it as a finish line. Here is the trap, and I do not think most people have noticed they are standing in it. Suppose the image is exactly what the collaboration says. The ring is real, the shadow size is right. The object is a Kerr black hole of 6.5 billion solar masses behaving exactly as general relativity predicts. Total success. Now look at what you have just confirmed. You have confirmed the existence of an object whose interior the theory itself declares undefined. Roger Penrose proved this in 1965, and it won him a share of the Nobel Prize 55 years later. His singularity theorem shows that once gravitational collapse passes a certain point, the formation of a singularity is unavoidable within general relativity. Not likely, not typical, required, given very general assumptions, and a singularity is not a very dense object. It is a place where the equations stop producing answers. Curvature without limit. A point at which the theory that predicted it announces that it no longer applies. So the confirmation is self-undermining in a way that has no equivalent elsewhere in physics. Every successful test of general relativity in the strong field, including this one, is additional evidence that reality contains regions where general relativity cannot describe reality. And it gets worse when you bring in the other pillar. Quantum mechanics requires that information is preserved. Take any physical system, evolve it forward, and in principle the initial state is recoverable from the final one. That is not a philosophical preference, it is built into the mathematical structure of the theory. Now throw a book into a black hole. Stephen Hawking showed in the 1970s that black holes radiate, and that the radiation appears to depend only on mass, charge, and spin. Nothing about the book. Let the hole evaporate completely, and the information about what fell in is gone, which quantum mechanics says cannot happen. That is the information paradox, open for half a century, and it has consumed some of the best theoretical physicists alive. There has been real progress recently, with results suggesting information does escape in a subtle way encoded in the radiation, and those results are contested and incomplete. Nobody claims it is solved. So the situation is this. Our theory of the very large and our theory of the very small give incompatible answers about what happens at an event horizon, and the horizon is where they are forced to meet. M87 star is not a curiosity sitting off to the side of that conflict. It is a photograph of a sort, of the seam. Now take the other branch. Suppose someone is right that it is not a black hole in the classical sense, that it is one of the horizonless compact objects, or something not yet imagined. That does not rescue anything. It detonates a different structure entirely, because supermassive black holes are load-bearing in cosmology. Every large galaxy appears to have one, and their masses correlate tightly with the properties of the host galaxy, particularly the velocity dispersion of its central stars. That correlation is one of the most important empirical facts in extragalactic astronomy. It is the reason we believe black hole growth and galaxy growth are coupled, and it underwrites how simulations of structure formation are built and calibrated. Remove the assumption that these objects are what we think they are, and you have not lost one exotic result. You have pulled a calibration out from under a field, and there is a live example of how shaky that calibration can be. Before the EHT, there were two mass estimates for M87's central object. Stellar dynamics gave about 6.5 billion solar masses. Gas dynamics gave roughly half that. Two respectable methods applied to the same object, disagreeing by a factor of 2, unresolved for years. The EHT measurement came down on the stellar side, which is a genuine and valuable result. But sit with the fact that this is the best studied supermassive black hole in the sky outside our own galaxy, and until 2019 we did not know its mass to better than a factor of 2. Now widen it, because this object is not passive. M87 launches a jet of relativistic plasma that extends for thousands of light years out of the galactic core, visible from radio to X-ray, one of the first ever discovered. That jet is not decoration. It deposits energy into the surrounding cluster gas, and that energy is what stops the gas from cooling and collapsing into new stars. Without it, the center of the Virgo cluster would be forming stars at a rate that observations flatly rule out. Translate that. A region smaller than the solar system, at the heart of a galaxy well over 100,000 light years across, is regulating whether that galaxy and its neighbors can make stars at all. The thermostat is the black hole, and the mechanism that couples the two, exactly how energy gets from a rotating spacetime out into a jet and across a cluster, is understood in outline and unresolved in detail. Some of the most interesting evidence for it is the polarization structure that EHT published in 2021, which showed ordered magnetic fields around M87 star of the kind those models require. So here is the full shape of the thing, and it is why I said at the start that this is worse than the headline. The apparent problem was an imaging question. Is the picture a photograph? That was never the real issue. The real constraint is that our two most successful theories give contradictory accounts of what an event horizon is. No observation can settle it because the boundary is defined by the impossibility of receiving information from beyond it. The population of objects, we can even attempt to resolve numbers too, and those objects sit at the center of the model of how galaxies come to exist at all. Every branch leads somewhere our physics does not currently reach. Confirm it, and you have proven that reality contains regions the theory cannot describe. Refute it, and you have destabilized the census on which structure formation rests. There is no comfortable version. Which leaves exactly one question worth asking about that image. So let us total it up, and I want to do this cleanly, because the case has been building for a while, and it deserves to be stated in one piece. It is not a photograph. It is a reconstruction, chosen from an infinite family of images, consistent with sparse interferometric data, using algorithms whose assumptions were set by human beings before the data was allowed to speak. It is not the event horizon. The dark region is the shadow, roughly 2.6 times wider than the horizon, and the boundary the instrument is named after has never appeared in any image ever made. It is not the black hole. A black hole emits nothing. Everything luminous in that frame is plasma outside the object, some of it seen from behind, wrapped around the front by gravity acting as a lens. It is not confirmable. No observation at any resolution, using any instrument built on any principle we understand, can establish that a true horizon is present rather than a surface that is very dark, very compact, or very slow. The evidence available is absence, and absence does not distinguish. It does not scale. There are two black holes in the entire sky, angularly large enough to attempt this. The array is at the diameter of the Earth, and near the limit the atmosphere allows. Improvement now requires hardware in orbit, on a timescale measured in decades, and it is not fully explicable. Taken at face value, it confirms an object whose interior general relativity declares undefined, sitting at the exact seam where our two best theories contradict each other. 6 statements. Every one of them either in the collaboration's own papers or a direct consequence of them. None of them in the headline. Now, here is the last comfortable illusion, and I want to take it away carefully because it is not really about black holes. The comfort was never in the physics. Nobody walked away from that press conference reassured about singularities. The comfort was in the belief that seeing something means understanding it. That is a very old instinct, and it is usually reliable. You look at a thing, you learn what it is. Photography extended it. Telescopes extended it. Microscopes extended it. 4.5 billion people looked at an orange ring and felt the specific satisfaction of a mystery being converted into a fact, and that feeling was the product being delivered that morning. But that instinct has a range, and we have now gone past it. At this scale, in this regime, an image is no longer a record of what is there. It is the output of a model constrained by measurements about a region we can only ever address from the outside. Looking stopped being sufficient, and the picture was so good that almost nobody noticed the transition had happened. So go back to the ring one more time, and let me describe it as it actually is. That light left a region of space where matter is being torn apart at a temperature of billions of degrees 55 million years ago, around the time the dinosaurs had been gone for about 10 million years, and the first primates were spreading through the forests. It traveled for that entire span across intergalactic space. On its way out,
It was bent by a gravitational field strong enough to fold the far side of the object into view, and some of it circled the object completely before it escaped. It arrived on Earth in April 2017 as a whisper of millimeter radio waves, was captured as apparent static by 8 dishes on 4 continents, time-stamped by atomic clocks, written to half a ton of hard drives, flown out by cargo plane, held on the Antarctic ice for 8 months by the winter, correlated in Massachusetts and Bonn, and reconstructed by 4 teams working blind who were not permitted to speak to each other until they were finished. And in the middle of what they produced, there is a dark region, and that dark region is not the object. It is the place where the light we can account for stops, and the place where our physics stops, and those 2 facts turn out to be the same fact. That is what was on the screen. That is what the applause was for. Now, the fair part, and it has to come last because it only means something after everything else has landed. The achievement is real. I have spent this entire time separating the science from the story, and I want to be exact about which one I am criticizing. The 2018 campaign, processed separately and published in 2024, recovered the same ring at the same diameter, with the bright spot rotated as the turbulent flow models had predicted. Independent groups, using entirely different mathematical frameworks, recovered a ring. The 2021 polarization results mapped ordered magnetic fields of the kind the jet launching models require. Sagittarius A* followed in 2022, a far harder target that changes faster than the Earth can turn. The measured shadow size agrees with a mass determined decades earlier by watching stars move. This is a technique that works, run by people who tested it against their own worst case before they believed it. That deserves to be said as plainly as the criticism. The problem was never the science, it was the sentence attached to it. Because we did photograph something worse than a black hole. We did not capture an object. You cannot capture that object, and nobody ever will.
What we mapped was the exact contour where our description of reality gives out. The place where the equations stop returning answers, where information goes and does not come back, where the 2 great theories of the 20th century look at the same region and disagree, and where no future instrument will arbitrate between them because the boundary is defined by the impossibility of hearing from the other side. We found the edge of what physics can currently say, and then we put it on a screen, colored it orange, called it a photograph, and celebrated it as a finish line.